Hello everyone, welcome again. So today we will talk about phase 2 of our application of Doppelganger or the celebrity lookalike application. Okay, as we said before, let me open my pen. So as we said before, this tutorial got two phases. Phase 1, which is the training we already done in the previous week, and this week we will focus on testing. Okay, so in the training, as we can see here, so we basically enter an image, okay, with the identifier to the image to the convolutional network. Then the output will be a model. Okay, the model representing a cluster of all the images that we input or we enroll to the system after we convert it into 1 by 128 long vector. Today or this week we will focus on the testing phase. By testing phase we will test our new model by inputting a new image of the same or different persons. Then we try to get their name, but we will not get the exact name because in this project we're not focusing to get exactly the same name. I mean the name of the identity or the name of the picture or the person, but we will find the closest person that look exactly same like the input picture. So how it will be, for example, here we inputting this image. Okay, again this raw image will not be good to submit to the neural network as it is. So first we have to pre-process it, align it, convert from PGR to RGB, and also we have to detect the face. Okay, we have to detect the face first. Then we predict the landmark. This is the point of the landmark around the face, and then we convert it into a vector with a length of 1 by 128. And this vector, after we convert it into a vector, this vector will be located somewhere, let's say around here, or let's say here. Okay, let's say this image, it's located somewhere here. Then let's change the pen color. Let's change to yellow. Is it obvious? Yeah. So then what we will do, we will calculate the distance from this image. Not really obvious. Let's change to black. Okay, we will calculate the distance of this image to all the other clusters. Okay, we will calculate the distance, how far this image that we already enrolled here, okay, or so it's not enrolled, but we already convert into the vector. So this vector is close to which of these clusters? Every cluster represents one person. Every cluster represents one person. So we will see this one close to which person. So for sure, this one is close to this person. Then from this person, we will get the name of this person and we display it. Then we say, okay, this picture of the X person is close to this celebrity, which is located here because it's close to it. Maybe another picture. Let's say we input another picture here. Sorry, but it should be looks like a picture here. Yes. When we input this another picture here, we convert it to 128 vector. Maybe it will locate it maybe somewhere here, or maybe somewhere here, let's say. And again, this one, when we calculate again, let me change the color. Let's take that this time. When we calculate the distance of this picture to all the other clusters in the model, then we will find that the cluster is close to, and this cluster is the closest to the to the vector which represent this image. Then we will say, okay, we will take the name of this person that's represented by this cluster, and we will return back. Okay, so this is the idea of our testing today. So let's go to the PyCharm environment, and we try to develop this code by testing the model that we already trained in the previous week, and we will see how close we can get. I mean, how similar and close pictures we can get to our inputs. Okay, let's go. Okay, guys. So this is the training code that we developed before in the last week. Okay, and the output of this code was to generate the model that name descriptors and also the index that contain the names of the pictures. So today we will work on the what we call the main code that we do testing on this model. So let's make new Python file. We call it celebrity lookalike test. Okay, so first of all, let's include the required library. So let's say here is to include the required libraries. So first of all, let's import for sure dlib, then import what else, for sure cv2, import we need the OS to join the path, and random, we see where we will use random, and also globe, maybe we're gonna use it, of course numpy as np. Sorry, what else we need? Let's import the matplotlib. Import matplotlib .pyplot as plt. Okay, so now we have done with declaring and importing all the required libraries. So now, first of all, let's find the route to the because here we need the route to the data or the pictures, because data we will use it to display which of the images that look, or the celebrity image that look like the input image. So route to the celebrity images folder. Let's call it Face Dataset folder equal to will be the celebrity mini. We copy the path, copy the name, because this one on the same folder. What else? What else we need? Okay, let's add also the what is it? Not the index, the mapping, the label map. So the label map equal to numpy.load. Okay, we will load what? Here we will load this one, the celebrity mapping. Yes, copy path, copy name, this one will be here. So we will load this by allowing the picker, allow picker picker equal to true. Then we open as item. I believe everything should be okay. Let's run. Yeah, should be okay. Yep. Okay, now we have to add the root to the dlib models. So we need the predictor path, and what else? We need the face recognition model. Okay, so the predictor, we will use a 68. There it is. Copy path, copy name. So this one will be for the predictor. And later we will use the dlib face recognition. We use the range set, copy path, copy file. Okay, this is to recognize the face. Next, we're gonna initialize the face detector. That's all there for the dlib. So face detector equal dlib dot get face frontal detector. Yep. And then we need the shape predictor equal dlib dot shape predictor. Okay. For this shape predictor, we have to include the path to the predictor. So we here predictor path. Then we have face recognizer. Face recognizer is the dlib dot face and recognizer model v1. Then and this one it's need the face recognizer model. Yeah, let's test out our code. Hopefully everything should be okay. Yep, okay, good. So now what next? Let's load our newly enrolled model. Okay, so face descriptor to enrolled, and we need the index. Okay, so the enrolled one will be numpy.load. We load the descriptors. Okay, copy the name. Okay, now we come to the index. Numpy.load. We copy this index, yes. Copy path, copy name. Okay. And for sure this one we allow the picker. True. Okay, let's try again. Beautiful. Next. So now we will add the source test image. Okay. So image equal to cv2.imRead. Okay. Let's see which image we choose first. Let's go. Sophia Solaris. We will take this as our first image. By the way, we haven't trained Sophia Solaris in the model in the first model. I mean, in this we don't have any Sophia Solaris. So let's see what will predict that which celebrity will be close to her. So the text Sophia Solaris. So we copy the path, copy the name, and be here. Let's display the image. Display the image. Let's use I am sure CV2. I am sure. I want to see the. First, we need the Windows name, source, and the image. Let's start. Should be okay so far. Yeah, let's go fast because we need the wait key. cv2.wait key. Wait forever. Yeah, need wait key to display the picture. Yep, it is our source. Good. So we don't need this anymore. So now from the Sophia Solaris, let's detect her face. So here, detect the source image face by using faces equal to face detector. But here, when we take the face again, we have to convert the image from PGR to RGB. Yes. So face detector of cv2.cvt color. We will convert the image and cv2.color underscore PGR to RGB. Yes, because the DLib require RGB. So here we will detect the face. Then let's display the face, or not display. Sorry, let's print out the detected faces. See how many faces being detected. If it's correctly detected. Again, okay. So here we can see the rectangular for the face. Okay, this is the X, width, Y, and the height. So here I guess no need to show anymore because it will be very fast and we have no time to see it. So face also okay, no need this. Now we have to go through the face because sometimes the image got more than one face. So we have to look through the faces. For the face, in the faces. Okay, so for the face in the faces, what we have to do first, we have to find the landmark. Find the landmarks. How to find the landmarks? By using shape equal to shape predictor. Yes. Then again, we pass the image after we convert. Actually, we should convert first to BGR, from BGR to RGB, so no need to convert. But it's okay, we already started. CV2.cvt color. And then we need the image. And CV2.color, yes, TGBGR. And also we have to send for sure the face that we detect. Okay, so after we detect the face, then next we need to compute the descriptor. So here we compute the face descriptor by using the neural network. And the dlib. Okay, so face descriptor equal to face recognizer dot compute face descriptor, and we need to send the image and the shape. Yes. Okay, so let's see how the face descriptor look like. This one actually is the what they call the vector. So let's print face descriptor. So this is the 1 by 128 vector, I believe. Yep, you see here. This is the vector, but now we have to convert it into a NumPy array. Okay, good. So it's converted now. Need to convert it to a NumPy array. Okay, how to convert it to NumPy array? We use a face descriptor, convert it to a list first. Face descriptor list m for m in face descriptor. And then the face descriptor array equal np dot as array. Then it take the face descriptor list, and then the type will be d type equal to np dot float 64. Okay, what next? We now convert again face descriptor array equal to face descriptor array np dot new axis. We add the new axis. Okay, so now we already have the array. Let's print it out. Let's print the face descriptor array. If everything is okay, we should see, yes, here's the array. So this is the vector This is the vector after we convert it into a NumPy array. So now we have this vector, and here in the in here in the face descriptor enrolled, we have the stacked because we already load this model. This model is the stacked vectors. So now we have to calculate the distance from this, okay, from this vector, the distance comparing to the stacked vectors that already stored here. Okay, so now we have to calculate the distance between the new image vector and the enrolled stacked vectors. Here to find what is the minimum or the smallest distance among all the stacked vectors, then we will assign this one that has the smallest or the nearest distance. It will be the one that look alike that image. So distance or distances equal to NumPy dot len dot normal we will find in the face descriptor enrolled, yes, minus face descriptor array. Okay, face descriptor array, yep, correct. And also we add the x's equal to 1. Okay, that looks good. So this is all the distances actually, sorry. This is calculate all the distances. Here we will find the minimum distance. So the minimum distance will be argument mini equal to NumPy dot argument mini of the distances. We find the minimum distance inside the distances. Then the mini distance equal the distance of the argument. Yes. So here should be distances. Yep. Sorry. So here already we find the minimum distance. So we have to at the same time find the label or the name. So label equal the index of the same minimum of the same argument that has the minimum what I call distance. So now let's try to print the label and see what we can get. Maybe you try to print the distance also. Here we go, Selena. So I believe Selena Gomez is the one that it will be look alike the Sofia Solaris. And also let's print the distance. I'm curious about the distance, so print the minimum distance Okay. 0.5. This is the distance, 0.5, and sorry, is close to Selena Gomez, I believe. Yeah. So now we have to loop through all the. Remember, just now we reloaded this one, the face dataset file or folder. We reload this. We have to go through this. We find where's the Selena. Then we display one image of the Selena compared to the input image. So here, for any key and value, and then label map, dot item, dot item. Oh, sorry, this one should be this for item. Now we check the value. If the value is matched with the label, I mean it's got the same Selena, then we will go through and display the images. So we check if value is equal to label. Here we are checking if the name of the celebrity is same as the label. If already same, again we have to find the subfolder, find the root or the path to that celebrity name subfolder by using subfolders equal to os.list directory faces dataset folder. Yes. Okay. So now we have the main subfolder. Now we have to go through each one of them. For each folder, again, and the subfolders. Okay. So now we go to the subfolders. We check if the folder is equal the key, because here when we find the value, when the value is equal to the same label, let's say Selena, we already found it. Here, actually the celebrity, if you see the celebrity folders, we don't have name here. Okay, so the value actually is the label map. The label map is this one. Label map is this one, the mapping. But here we don't have any names. So this one is the name. Key is the number of the subfolder. Okay, so now we already find Selena. Okay, Selena, let's say number N0006. So find Selena now. Now we're still in Selena. We take the number of the Selena folder, say 00 and 0006. So if this folder is matched with the key, then we say that the celebrity name is equal to the label map of that folder. Okay. Then the image file equal os.list directory So now for the list directory, what we will join the os.path, path join, path.join, not the join. Sorry, path join. We will join the Face Dataset folder. So now this is the main folder with the subfolder, which is the folder. Okay. Now we reach to the folder. Let's say we reach to this folder 006. This 06, if you see, we have 1, 2, 3, 4, 5. We have 5 images. So we will choose any random image of them. So random underscore img equal to random choice from the image files. Okay, we take any random image from this one, for image file. Then we find them. We find the full path to the final celebrity image. So the final path equal os.path.join. So now we join what? We join all the 3 parameters. We join the main, sub, and the name of the random image. Okay. So we join the face dataset, we join the folder plus the random image. Okay, so we join the face dataset folder, which is the main, which is the celebrity mini folder, is which one of them? Let's say this one. Then the random, that it will choose one of them. Okay, good until here. And after this, after we find the final path, then we just read the image. So celebrity image equal to cv2.imread celebrity image. Okay, I will read the celebrity image, the final path. Okay, we will read this image. Okay, so after I read this image, I know it because sometimes it will keep go through. For example, we find here, if it's go more than, let's say we enrich more than this one, it will keep reading. So after it will reach the required image, I need it to be break. So here need to be break, and that's all, I believe. So here we display the results. So plt.subplot here, because I will display both source and destination, or source and the result in the one figure. So it will be 1 to 1 and plt.IamShow. First will be the source or the input image. Because you have to convert to PGR again, and here will be colon. Okay. So here is the input image, and here is the results. So the result will be again blt.subplot 122 plt.IamSure. So IamSure will be the celebrity image. Yes, celebrity image, and again we need to convert to VGR -1 and need here plt.title will be celebrity. Let's make this capital. Celebrity lookalike equal to this. Sorry, this one should be in quotation. Here dot, we format it here, will be the label. Okay, and for sure at the end will be blt.show. Okay, the moment of truth. Let's run and hopefully we can see the result. Nice. Oops. Subfolder expect an indent. Where is it? Ah, yeah. For sure should be here. Okay. The SET is no item. This one I believe is the label map. Where's the label map? Why? We already actually added here. Okay. This one correct. Correct here. Oh, should be items. Okay. Now should be subfolders. Where? Subfolders. Yeah, should be same. Let's copy. Subfolder is not defined. Why? Subfolder. Actually should be okay here. Do you know what? I believe this all is out of the indentation. Should be, yeah, because we're still under the if. And and this one should be here. Yeah. Sorry, too many structure errors. Now should be okay. Yep. Nice. Here we go. So this is the input. The output is the Selena Gomez. So let's change the picture now. Very nice. Let's change the picture now. Sorry. Let's change the input picture. What is it? Should be here. So let's go, for example, to here, to this one. Change count. Let's see who looks like. Okay, these two pictures we are not enrolled them in the. Yep, is Amitabh Bachchan. They really actually they look alike. If you can see, both of them they looks alike. Okay, let's change to this. Copy path, copy name. This one takes a bit time. Yep, we can see actually there is not really, but quite look alike. Nice, Jack G. Griffo, sorry. Okay, let's take another one. Maybe this. Let's see who looks like this picture. Jack Cherry. Okay, Jack Cherry. That's good. That's good. So we can see. Let's see this. Yeah, we can see they are close, not 100%, but almost okay, acceptable. Yeah, kinda. You can see like the face also looks round, almost same. Chilean. So okay, let's go through again. So here we define the required libraries. We go through the folders. This one not need anymore. So we go the folder of the images that we require to display it at the end of the app. Okay, and here's the model we use to detect and predict the face details. Here we initialize all the dlib parameters for detector and predictor and also recognizer. And here we load the model that we already trained at the last week. Here we load our source image. Then we detect the face. Then we go through each face because some of the images got more than one face. So we go through each face inside the faces. We take the landmarks. We compute the vector. Then from the vector we convert into the NumPy array. After we convert to the NumPy array, we take this vector and calculate the distances, all the distances among all the stackable vectors inside the descriptors. So actually the descriptors is just vectors that we already stacked together as we described last week. So we calculate all the distances, then we find the minimum distance, then from the minimum distance we find the label that shows the name of that celebrity. Then from the label we go to check which one of the celebrity it is. If we find the name that match that name in the label, then we go to that subfolder and we build the folder. From the main folder we go to the subfolder. This is the main folder, this is the subfolder. Okay, and now we search for the key, also the folder that match the key. That match the key actually is the name of the subfolder. Then from there we will find a random image from the 5 to display. Okay, then we calculate the final, or we find the final path to that image of the celebrity image, then we load it. And after we load it, then we just display. We display a result. First, we display the input image, the main image or the raw image that we input to the system, and also we display the celebrity that's been suggested by the program. So that's good. I'm happy with the result. So I hope you like it and you hope you have learned something new with this. So yeah. Thank you very much, and let me know if you have any question or any comment. For sure, this is not the perfect one. There is a lot of better ways to do this celebrity lookalike, but this is my way to do it. Please leave me any comment if you have any suggestion and questions. Thank you very much and see you soon.